Welcome to today's Explainer. We're looking at the AMOC collapse and Europe's looming ice age. Now, I know it sounds completely counterintuitive, but the record-breaking global heat waves we're experiencing today, they might actually be the exact trigger that plunges Europe into a deep freeze. Let's uncover how. Okay, let's dive right into this because this mind-bending paradox is really the key to understanding an incredibly fragile balance on Earth. Think about it. How does unprecedented global heating lead to an era of freezing temperatures in one specific region? Well, to understand this anomaly, we have to completely rethink why Europe enjoys the mild climate it has today. And to do that, we need to look far beyond the continent itself, deep into the icy waters of the Atlantic Ocean. To set the stage here, let's compare cities in North America with European cities that share the exact same latitudes. When you do that, a massive discrepancy pops up. Look at New York and Madrid. They both sit right on the 40-degree north line, yet Madrid is noticeably warmer in both the summer and the winter. Or take Calgary in Canada compared to Frankfurt in Germany, both at 51 degrees north. In December, Calgary is freezing at an average of minus 12 degrees Celsius, while Frankfurt sits comfortably at 8 degrees. I mean, that is a staggering 20-degree difference for two cities sitting on the exact same horizontal line on the globe. So why is Europe so disproportionately warm compared to its North American neighbors? Well, the secret actually lies in a massive, invisible ocean current acting like a global heat conveyor belt. This natural system is called the Atlantic Meridional Overturning Circulation, or AMOC for short. It's a vital part of a much larger network of ocean currents that transfer heat across the globe, but the AMOC specifically focuses on moving vast amounts of thermal energy straight through the Atlantic. And that is exactly what keeps places like Britain, France, and Scandinavia surprisingly comfortable. To really get this, we have to look at how this incredible conveyor belt actually operates. It starts with powerful winds driving warm surface water from the Gulf of Mexico all the way toward Europe. As this water travels, it's continuously warming the climate of northern Europe. Then, the water keeps on its journey, heading all the way up to the icy regions near Greenland and the Arctic. Up there, cold, dry winds cause a lot of this water to evaporate. As temperatures plunge, sea ice begins to form, and that leads to a fascinating chemical reaction. This reaction powers the rest of the cycle by creating incredibly heavy water that travels thousands of meters deep, all the way back down to Antarctica. So the crucial point here is the exact mechanism making that water sink, which is known as brine rejection. Basically, when seawater freezes into ice, the crystal structure actually has no room for salt, so it expels it into the surrounding liquid ocean. Because of this really high salt content, the freezing point of the water drops, meaning it stays liquid even at minus 2 degrees Celsius. This super salty, freezing water becomes extraordinarily dense and heavy. That massive sinking action right off the coast of Greenland is the literal engine pulling the entire AMOC conveyor belt forward. But here is where we have to pivot to the terrifying reality of the present day. Global warming is dangerously altering this really delicate oceanic chemistry. Right now, the massive ice sheets of Greenland are melting at an alarming rate due to rising global temperatures. As these ancient glaciers melt, they're pouring millions of gallons of fresh, non-salty water directly into the North Atlantic Ocean. And on top of that, because the region is generally warmer, less sea ice is forming in the winter. So less sea ice means less brine rejection is happening to create that vital, salty, sinking water. And this brings us to a pretty tragic irony. This massive influx of fresh water is diluting the ocean's salt levels. Because fresh water is less dense, the water around Greenland simply isn't getting heavy enough to sink anymore. And without that downward pull, the conveyor belt loses its fundamental fuel. Basically, the entire AMOC system begins to stall, which threatens to completely stop that vital flow of warm water from Mexico to Europe. Now, what's really interesting about this is that scientists aren't just guessing anymore. Back in 2004, an international team deployed something called the Rapid Array. It's this complex system of underwater sensors stretching from the Bahamas all the way to the Canary Islands, designed to measure the AMOC's flow, temperature, and pressure in real time. When they started measuring, the current flowed at about 18 to 19 sverdrups. But today, it's dropped to between 15 and 17. This gives us undeniable mathematical proof that the current is in a steady downward trend. To really grasp what a sverdrup is, we have to appreciate the sheer scale of these measurements. 1 sverdrup is equivalent to 1 million cubic meters of water. To put that into perspective, that is exactly 1 billion liters of water flowing every single second.
So when we talk about a drop from 19 down to 15 Sverdrups, we're talking about losing billions upon billions of liters of warm water per second that are no longer being pushed through this oceanic pipeline to warm up the European continent.
That calculates out to a shocking 16% drop in flow over just the last 20 years. A recent geophysical research paper noted that the AMOC flow is currently declining at a rate of roughly 1 Sverdrup every single decade. And the truly terrifying scientific projection here is that if this flow drops down to the level of 6 Sverdrups, the system won't just slow down. It will enter a complete shutdown phase. And since the cycle takes thousands of years to complete just one loop, once it stops, it's going to take thousands of years to ever start up again.
Now, if you're thinking a total shutdown sounds like something out of a science fiction movie, let's look back at the historical record, because this has absolutely happened before. Around 12,000 years ago, right as the last natural ice age was ending, massive North American and European ice sheets melted rapidly. That fresh meltwater flooded the ocean and killed the AMOC cycle entirely. The heat coming from the south immediately stopped flowing, and temperatures all across Europe plummeted by 5 to 10 degrees Celsius. This deep freeze lasted for roughly 1,000 years before the AMOC eventually stabilized and restarted.
And this brilliantly illustrates how we actually know this happened. Paleoclimatologists were digging deep into the Earth to extract these 10,000-year-old soil and ice cores, and they discovered a massive abundance of pollen from a plant called the Dryas. Now, the Dryas is this rugged flower that naturally only grows in the freezing Arctic Circle. Yet, its pollen was discovered buried all across ancient European soil. That proved beyond a shadow of a doubt that Europe was once transformed into a frozen wasteland by a stalled AMOC. This fascinating period in history is now famously known by scientists as the Younger Dryas.
But here's the thing, we are already seeing the warning signs of a modern-day Younger Dryas. While almost everywhere on Earth is showing undeniable warming, right near Greenland, there's a distinct thermal anomaly known as the white blob. This patch of ocean is actually getting remarkably colder. It's literally the only place on Earth reacting this way right now. And it perfectly aligns with the theory that cold, fresh meltwater from Greenland's glaciers is currently pooling on the surface, disrupting the ocean's delicate balance exactly where the AMOC engine should be churning.
So, let's look at how this builds into the dystopian reality of a complete AMO collapse today. If this conveyor belt stops, Europe as we know it changes forever. Cities like London and Dublin, which currently enjoy pretty mild weather, would routinely plunge to -15 or -20 degrees Celsius in the winter. Northern European agriculture would completely fail, just unable to grow in that kind of frost. Vital ports that currently operate 365 days a year would freeze solid. Energy grids would absolutely collapse under unprecedented heating demands. And perhaps most devastatingly, we'd see massive reverse climate migration. Millions of Europeans would become climate refugees, forced to flee south towards Spain, Italy, or North Africa just to survive, all while trapped heat in the South Atlantic would relentlessly scorch South America and Africa.
Which brings us to the ultimate realization here. Nature's balance is just unfathomably delicate. We often assume that global warming simply means everything everywhere just gets hotter. But the unraveling of this invisible deep-water conveyor belt shows us that excess heat in one place can actually trigger a catastrophic freeze in another. We're tampering with systems that operate on a massive planetary scale. So as we watch the Greenland ice melt and we monitor those dropping Sverdrups, we have to ask a haunting question. Are we too late to save the engine of the Atlantic? And is Europe truly preparing for the return of the Ice Age? Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll see you next time.